Good evening, everyone. So, welcome to my YouTube channel, Sastra. So, today we are going to see ninth lecture on infinite series. Today we'll study ratio test. Ratio test is also called D'Alembert ratio test. Okay, so ratio test is what is the ratio test? Ratio test. Okay, so let summation n goes to 1 to infinity an be any series and suppose that limit limit n tending to infinity an plus 1 upon an is equal to rho, then a part the series converges absolutely if rho value is less than 1. Second part b, the series diverges if rho value is greater than 1 or rho is infinite. Either rho is greater than 1 or rho is infinite. In that case, the series diverges. Third case is that the test is the test is inconclusive inconclusive if rho value is 1. Okay, so let's see its proof. So a part we are proving. So rho is less than 1. Okay, less than 1. Now let R be a number such that R is in between rho and 1. Okay, put epsilon is equal to R minus rho. Okay, then this is a positive. Since limit n tending to infinity an plus 1 upon an is equal to rho, we get there exists capital N belongs to n such that an plus 1 upon an minus rho less than epsilon for all n greater than capital N. Okay, so this implies epsilon minus rho. This implies this implies rho minus epsilon is less than an plus 1 upon an rho plus epsilon for all n greater than capital N. So taking this part only, so this implies an plus 1 upon an is less than but this is nothing but R. Okay, for all n greater than capital N. Okay, rho plus epsilon is R because epsilon is R minus rho. So we have this one. So this implies a n plus 1 less than R a times a n for all n greater than capital N. So this is true for n. So this implies a n plus 1 is less than R times a n. Okay, a n plus 2 is less than R times a n plus 1. But a n plus 1 is less than this, so this implies R square a n. Okay, so what is a n plus 3? That is less than R a n plus 2, and a n plus is R 3 a n by this from here. So, continuing in this way, so what we have a a n plus m is less than R to the power m a n. Okay, for all m belongs to natural number. Therefore, summation m goes to n to infinity am is equal to summation m goes to infinity. I can write like that: a n plus m, that is less than m goes to 0 to infinity a n r to the power m. Okay, r to the power m a n. Okay, so this will come out summation m goes to 0 to infinity rm. Now this is a geometric series with less than 1. So this is convergent. Okay, since as this series summation m goes to 0 to infinity r to the power m is convergent, this implies a n times summation m goes to 0 to infinity r to the power is also convergent. Okay, is convergent. Now by comparison test, comparison test part 1, we get this series summation m goes to n to infinity a n am is convergent. So this implies summation n goes to 1 to infinity a n is also, because adding finite numbers of terms in a convergent series, the convergency or divergency of a convergent, sorry, adding finite numbers of terms in a convergent or divergent series do not change the nature of the series. If some series is convergent, it will remain convergent. If some series is divergent, it will remain divergent. So this is convergent. So this implies is absolutely convergent. Okay. Now B part, case B we are taking like this. So if is this like this, okay. So as limit n tending to infinity, an plus 1 upon an is equal to rho, and rho is greater than 1. Okay. Now choose r greater than 0 such that rho minus r is equal to epsilon is greater than 0. Greater than, we can choose r such that this is greater than 0. Okay. Choose r greater than 0 such that this is greater than. It is possible. Now put epsilon is equal to rho minus r. Okay. Now limit n tending to infinity, an plus 1, an is equal to rho. So there exists m belongs to capital N such that so this implies there exists such that an plus 1 upon an minus rho less than epsilon for all n greater than capital M. Okay. Capital M. So after solving it, what you will get? This will be rho minus epsilon. Sorry. Yeah. Rho minus less is greater than an plus 1 upon an less than rho plus epsilon for all n greater than capital M. Now taking this part, rho minus epsilon an plus 1 on an for all n greater than capital N. So what is rho minus epsilon? Rho minus epsilon is R. Rho minus epsilon is R. Okay. Is an plus 1 upon an for all n greater than capital N. So this implies so what is this? So actually we can choose because rho is greater than, we can choose r greater than 0 such that rho minus it will remain positive. It is possible because rho is greater than 0. We can choose r greater than 0 such that this will happen. Okay. So we have this one. Now this is greater than 1. So what do we have? We have this one. an plus 1 upon an for all n greater than capital M. So this implies an is less than an plus 1 for all n greater than capital M. Okay. So it means what? It means am is less than am plus 1. Am plus 1 is less than am plus 2. So after combining this will imply am is less than a am plus 1, that is less than am plus 2. So this will go in continuation. Okay. So what is the limit? So this implies am plus m is greater than am for all m belongs to natural number. So this implies limit. So this implies because each term is after certain stage, each term is greater than this. So this implies an does not tends to 0 as n tending to infinity. Okay. So this implies if a series is convergent, its nth term tends to 0. So this implies this series, okay. So this implies this series an diverges. Okay, diverges. Okay. Now C part, if rho is equal to 1, then take this series summation n goes to 1 to infinity 1 upon n and summation n goes to 1 to infinity 1 upon n square. Now for summation n goes to 1 to infinity 1 upon n, what is an plus 1 upon an? That is n upon n plus 1, and that tends to 1. It means rho is 1. Okay. Now for this series, and for this series 1 upon n square, what is an plus 1 upon an? This is n square n plus 1 ka square, that is n upon n plus 1 ka square, that is also 1. Okay. In both series, in both cases rho is 1, yet the first series, this series is divergent, we already know, diverges. whereas the second series summation n goes to 1 to infinity 1 upon n square converges. Hence, if rho is equal to 1, then test is inconclusive. Closive. So this is done. Now we will see some example. Example number 1. Example 1. This series summation n goes to infinity. 2 to the power n plus 5 upon 3 to the power n. What is a n is here. So then what is a n plus 1? You put n plus 1 in place of n. Now what is a n plus 1? A n plus 1 upon a n. What is this? So what is this? This will become by solving. You will get this one. After solving, you will get this one. So this implies a n plus 1 upon a n. What is this? This is 1 upon 3. Because this is a positive thing. So what is the limit? What is this limit? This limit is nothing but limit is nothing but 2 by 3. That is rho, and rho is less than 1. Rho is less than 1. Okay, that is rho, and that is less than 1. So this implies limit n tending to infinity a n plus 1 upon a n, that is rho is less than 1. So by ratio test, the series summation n goes to 1 to infinity 2 to the power n plus 5 upon k to the power n converges absolutely. If a series converges absolutely, this implies the series converges. Absolutely convergent series is convergent. So this series convergent. Converges. Okay. Example 2. This series summation n goes to 1 to infinity factorial 2n factorial n square. So what is a n? Factorial 2n upon factorial n square. So this will imply a n plus 1 will be 2n plus 1 upon factorial n plus 1 square. Now a n plus 1 upon a n, what is this? This is factorial 2n plus 1 upon factorial 2n, and this will be factorial n plus 1 square upon factorial n square. So after solving it, what will get? 2n plus 1, okay, and 2n plus 1 on factorial 2n, then factorial 2n it will be, and it will be n plus 1 square factorial n square upon factorial n square. So this is cancel out. This is also cancel out. Oh, sorry. This will, I made mistake. Okay. So this will be factorial n square, and it will be factorial n plus 1 square. Okay. So what is this? This is 2n plus 1, 2n plus 1 factorial 2n. Okay. This is factorial 2n factorial n square, n plus 1 square factorial n square. This is cancel out. This is cancel out. And one power will be cancel out here. So it will be n plus 1. So this is an plus 1 upon an is equal to 2, 2n plus 1 upon n plus 1. Okay. So what is this? This is implying an plus 1 upon an is equal to 2, 2n plus 1 upon n plus 1. What is the limit of this? Limit n tending to infinity an plus 1 upon an is equal to, this is going to be, limit will going to be 4. Okay. So rho is 4. So that is greater than 1. So this implies rho is equal to 4, that is greater than 1. So this implies the series diverges. By ratio test, by ratio test, the series diverges. Okay. Now what about this? Example number 3. Example 3. So this is limit n tending to infinity 4 to the power n factorial n square factorial 2n. Okay. So what is an? This is this. Okay. So what is an plus 1? 4 to the power n plus 1, n plus 1 square 2n plus 1. Okay. Now an plus 1 upon an, what is this? This is 1 upon 4, 2. Okay. 2, 2n plus 1 upon n plus 1. Okay. So to cancel, this is 2n plus 1